a reminder of where we got to yesterday then. So we were talking about arithmetic sequences or series. Series is just a sequence where you're adding it up. We had a formula for any term in that sequence, which is start at the first term and then it's n minus 1 jumps. So to get from the first to the fifth term, that's 4 jumps. And we then had, at the end of the lesson, the sum formulas, 2 of them, formulae I suppose I should say, both of which start a half of n or n over 2. One is just first term added to the last term. That uses that little trick that I showed you. And that works for any sequence, not just the natural numbers added up. And then if you work out the last term using that formula and simplify it all, you get that. And those are on the formula sheet, and you don't need to remember them. So let's just very quickly practice doing that for a couple of sequences. So if we just do 1a and b. So in question 1, I'm going to start by writing out the bits I need, the parameters of the formula, of the sequence. So a, the first term is 3. I can see it's an arithmetic sequence, and I can see the jump is 4. That's D. And I'm told there are 20 terms. So can I just get you to find the sum of the first 20 terms of that sequence, and then do the same for part B, just very quickly. It's only when you watch yourself on a video that you realise how much I talk and how little time I give you to practice, and that's partly because there's a lot of stuff to get through, but I do need to make sure I give you more practice. This is on page 64. So although it's not in a bracket here, I always do that times that in a bracket. So I've got 2 lots of A plus these 2 multiplied together. So I put those in a bracket. So I've sort of got, 3 brackets almost, haven't I? I've got that and then that. Gets big quick though, doesn't it? Just wait till we do geometric series where we're multiplying. So the formula's on the formula sheet, so nothing to learn, just need to know how to use it. And I think it's a really good idea in any sequence question to write out the parameters. So in this case, we've got 3 parameters. The first term A, second term, a difference, common difference, the jump, D, which can be negative if it's a sequence that's going down, and N, which is the number of terms. I think that's 450, the second one, is it? Okay, still quickly, because I want to get on to some more problem-solving questions. Here's a slightly different question, where we're asked how many terms are there in this sequence. So this time, I'm going to write out my parameters, but it's going to be slightly different. So I know the first term, so A is 5, and I know the difference, that's 3, and I know the sum, although I don't know how far that sum is. What I don't know is N. So it's a little bit like going back to Suvat, isn't it, where we started by sort of writing out what we knew and what we wanted to find out. That's what I want to find out here. So I know that this is this formula here. Now I can't help noticing that N features twice in this formula, and it's multiplying, so we perhaps should be expecting a quadratic here. So I'm going to plug in my numbers, but I don't know N, so forgive me if I'm going to write that as N over 2. Half of N over 2, same thing, isn't it?
You might have to read the same list. But then you might have, no, maybe 3 once, or maybe twice.
Now, looks a bit odd inside the bracket here, but the first thing I'm going to do is deal with this. Don't like fractions, so I'm going to double everything, and I need to be careful here. If I double this side, well that's okay, I can do that, that's going to be 1,340. But doubling this side, I mustn't think that means doubling this, you know. If I want to double this, this is something being multiplied by that, so I only need to do this. That's being doubled, okay? N over 2 times that, and N over that, that's been doubled. So now I've got multiplying all that out. So this, we normally have the 3 in front of the bracket, but it's 3 times N and 3 times minus 1. Sort all that out, multiply it by N, you'll find you've got a quadratic. Line your quadratic up, taking the 1,340 over, and you should hopefully be able to solve it using your calculator. Have a go, see how far you can go with this, and maybe some of you will have a go. So this step here, I think, is the key step. You know, if you've got 3 times something, 6 times something is twice as much. You don't need to double the something as well. So here I'm going from N over 2 to N. I've doubled it, doubled that size. I've then sorted out my bracket, 3 times N and 3 times minus 1. Simplified that, 10 take away 3 is 7. I then multiplied by the N outside, and then lined it all up. And that gave me this quadratic here. And when I went to my calculator to solve that, it gave me one value which seems to make sense, and another value which is complete nonsense. And you can't have that number of terms in a sequence. It's negative and it's not a whole number, so it's wrong on 2 levels, and so that means that N is 20 is the answer. And it might be worth you, if you haven't had a go at any of those others, may be worth adding 2B to your independent study list, because I think that process of when you know the sum, finding the number of terms is a process worth working through. And if you've done it, that's good. Yeah. So we are on page 64. Page 64. And yeah, this is an example of series involving a problem we've met elsewhere. This time it's quadratics. Buckle up, because we're going to be meeting logs as well along the way. in order to solve problems, not to do with arithmetic series, but to do with other sequences. So there we go. Right, so the practice I think is worth you doing is on the next page. So I think if we have a go at a few questions from the next page now, and again, this will be questions that I recommend we'll go through a couple now, but I really want you to have a go at some independently. So 3, 4, 5, 6 and 9 I've identified as good ones to try. So these are all to do with the sum of arithmetic series. And I would strongly recommend that where possible you start each question by writing down your parameters. Do I know what A is, the first term? Do I know what D is, the gap, the constant difference? Do I know how many terms I'm dealing with? Do I know the sum? And then you've got your 3 formula, which you may be using one of them or both of them, or sorry, both. One of them or more than one of them. So we're on page 65, questions 3, 4, 5, 6 and 9. With question 4, I wonder if there's 2 ways of doing it. You could do it with an inequality, couldn't you? You could say, right, I want to know the value of n that makes the sum greater than 1,000, so I'll just have n over 2, 14 plus n minus 1 times 5. I know we've always got that sort of the wrong way round. And the first thing I'd do in that case would be to double. But it might be that the whole inequality thing unsettles you a bit. So what you could do is this. You could say, okay, how many terms do I need to make the total exactly 1,000? Now the chances are that the total won't ever be exactly 1,000. It'll be less than 1,000, and then you'll get a term that makes it more than 1,000. So the chances are I'm going to get an answer here which is not a whole number. But of course I can say, well, okay, that means it will be greater than 1,000 with the next number up. So I'm wondering if the whole inequality thing unsettles you, maybe this approach might be a little bit easier. I'm going to do both in a second, just to sort of just to see if we can unpick what's going on. So using my equals 1,000 method, I get 19.12 and minus 20.92. That's a nonsense answer, which is always going to be there. So I know that when n was 19, because n can only be a whole number in a sequence, it's the number of terms. When n is 19, I know the sum was less than 1,000, so the 20th term would be the first term that made the total bigger than 1,000. Now if I'd left it in an inequality, hopefully you would have been able to interpret it in the same way. I mean, I always solve inequalities, quadratic inequalities with a little graph. So what we're saying is that this equals 0 at 19.12 and minus 20.92. So there we go. So my solution is it's greater than 0 either before minus 20, well that's nonsense when we turn to a sequence, or after 19.12. It's the same thing. So I just, you know, some people cope very well with inequalities and it's not a problem at all, but sometimes it's a bit of a thing. So make it equal to 1,000 and just realise you're not going to get a whole number. The answer's 20 anyway. The answer's 20. So for number 5, I find the difference using the formula, and then I want the 20th term, so I go to the other formula which says the 20th term is the first term plus 19 jumps, and the first term is 4, and I need to do 19 n minus 1 times minus a half, which is 19 times minus a half is 9.5, so it's minus 5.5, yes. Now, again, I'm sorry I'm moving things on, but we've got those questions there to try. I want to attract your attention to question 6, because remember I said sequences gives examiners a chance to test all sorts of other skills. So we've already come across quadratic equations. But question 6 features another problem, another sort of maths, because we're barely told anything about this in terms of the parameters. We know the sum of the first 3 terms is 12, and the 20th term is minus 32. So we don't know any of our parameters. We don't know A, and we don't know D, and well, N, there isn't really an N. It's So what I've got here are two facts, that the sum of the first 3 terms is 12. Okay, so for that one, I know that the number of terms is 3, and the sum of the first 3 terms is 12. So I can plug that into my sum formula. So the sum is equal to n over 2 times 2a plus n minus 1, that's 2d. So that's using my formula for the sum, and I've just plugged in all that I know. I only know that n is 3 and the sum is 12. I'm going to double everything just to make that a little bit easier. And then I'll multiply out my brackets just. And actually I can divide everything by 6, that makes it nice and easy, doesn't it? Don't have to do that, but there we go. So I substituted that into the n over 2, 2a plus n minus 1 d formula. So I don't know a, so I have to leave it as 2a. I know n is 3, so n minus 1 is 2, but I don't know d. So there's a whole lot we don't still know. But that's the first fact. The second fact I'm given is that the 20th term is minus 32. And I know a formula for the 20th term, don't I? That's un is a plus n minus 1d. So I know that minus 32 is the first term plus n minus 1, 19 jumps. So what sort of problem do we have here? Second-times equation. And the good thing is, of course, that at this point in our maths experience, we are not expected to be able to, we can, but we're not asked to solve that. We can use our calculator. So calculator into equation mode. It thinks in terms of x and y, we think in terms of a and d. I mean, some of you will be able to work that out anyway, because going from first equation to second equation, we're adding 18 d's and it's making the total 36 smaller. So see if you can finish that one off. Just in case there's any doubt, so it's a simultaneous equation with two unknowns. So it's expecting it in terms of x and y. So I'm just going to type in 1a plus 1d equals 4. And 1a plus 19d is minus 32.
Brilliant.
And then it tells me that xa is 6 and d is minus 2. So we met quadratic equations and simultaneous equations as part of this. So the other thing that people like, and again, if you haven't done question 9, make a note, have a go at it. But the other thing they like to throw in are missing values within the sequence itself. Well, all is not lost, George. All is not lost. So this is question 11 on the same page 65. And we mustn't be thrown by the fact we've got missing values in there. I'm still going to use my same approach. I'm going to see if I can write down the parameters of this sequence. So do I know the first term? Well, I do. It's k plus 1. Do I know the difference? What's the difference then, George? K plus 2. Yeah, and that's a key point. Going from here to here, I'm adding k plus 2, and going from here to here, I'm adding k plus 2 again. So the difference is k plus 2. I don't know the number of terms, but I know the sum of those terms. So I know, but I know the nth term is 303. So the first question is about the number of terms. So I'm going to use my UN formula. And that's going to allow me to work out work out n, but it's not going to be a number, it'll be k's in there. So we know that the nth term is 303, but we don't know how many terms that is. So see if you can plug those numbers in. Let's see if you can get some of the rest of this question. Part 2 is about the sum, so you're going to use the sum formula in part B. Sorry. Bit of a mess, isn't it? It's okay. It's all going to end happily. So I've firstly selected the correct formula. So this first part wasn't about the sum, it was about a specific term, because I know that the last term is 303. So I'm saying, okay, if the last term is 303, what does n have to be? How many terms is that to get to 303? And that involved this bracket here, n minus 1, which is in the formula, times d, which is k plus 2. Gridded it out, Doesn't look very nice, but it gives me kn minus k plus 2n minus 2. Now the minus k is good news because that cancels out with that k, so the k's disappear. And I've got 1 take away 2, which gives me minus 1. Gets me to here. Now, I want an equation that says n equals how many terms? And so again, we've got this situation where n is twice in the equation. So we get to use my favourite algebra trick. Let's get everything that doesn't have an n on one side. I can do that easily by adding 1 to both sides. And then I get to use my favourite trick of all, 2 n's all of a sudden magically become 1n. That process of factorising allows me to write it like that, and therefore I've done what they asked. I've found the number of terms in the series in terms of k. So I'm going to fill that in my parameters. It's not pretty. So the sum formula is this. Except I know the last term, don't I? So I could carry on with this version, but actually, do you remember there's a simpler version of the formula where, if you know the last term, so I could use that. That's going to be a little bit easier. So I've got n over 2, and which is this divided by 2, and I've got a, which is k plus 1, and l, which is 303. So if you've already started using that, fine, you're going to be fine. Would anyone like to suggest how I could write half of 304 over k plus 2? I've got to write n over 2.
What's the last term?
Yeah. Well, okay. Half of 4/3 is 2/3. So n over 2, half of this, I could write as 152 over k plus 2. That's one way of writing half of that. I could also have, yeah, no, I think that's the easiest way. And at that point, because of what I'm being asked to write, I'm going to rewrite this like this. I'm thinking of that bracket as being a fraction, that bracket over 1. So I've gone from here to here, and hopefully from there you can finish it off. See if you can get to the end. I mean, this hopefully you can see multiplies out. I mean, I'm crossing my fingers and hoping that 304 times 152 does give me that number there. I'm assuming that's correct. And then for part C, all I've got to do is I've got to say, well, this is my formula for the sum, and if it equals that, then all I need to do is say, right, okay, and I hate fractions, so I'm going to multiply both sides by and although I was a bit worried I was going to have to deal with some horrible algebra, actually, sorry, the only horrible thing is the way I'm setting this out, it's not going to be too bad at all, is it? So I've got 2568k plus whatever 2 lots of 2568 is. and then it's take that from both sides. And take that from both sides. Come out of 17, 4, 1, 0, 7, 2. So this is a definite step up in difficulty, isn't it? Firstly, because it's the first question we'd met where we needed to decide which formula to use. It wasn't obvious. So part A, we used the UN formula for a particular term. Part B, we used the sum formula. And then part C was just a little bit of algebra. So I like sequences because it practices our sort of algebra skills. Today we've done simultaneous equations, we've done quadratic equations, and we've done loads and loads of sort of algebraic manipulation. So it's a good skill to have. It's good to have a topic that practices those key things. Okay, tell you what. Let's look at the first question we're going to do next lesson, which is on page 84. And question 2 on page 84. In fact, I tell you what, I might get you to do this yourselves before the next lesson. So I'll be honest with you, questions in exams either look like the one we've just done with the missing values, or like this. You're unlikely to get one like the ones we were doing right at the beginning. So they are trickier, but I like these questions because actually they're not as hard as they look. Yeah, these are wordy, which we sometimes think it's a little bit not my thing. I'm maths, I should be doing numbers. But actually, if you look into them, it's not too bad. The first thing you need to realise is it's an arithmetic series question. So Carol starts a new job on a salary of 20,000, and she's given an annual wage rise of £500 every year. So I might even draw a little picture here. So we've got 20,000, 20,500, 21,000. And it carries on until she gets a salary of 25,000. So for part A, we're asked how much in total does she earn in 10 years? Not how much is she earning at the end of 10 years, but the first year plus the second year plus the third year. So I'm going to write my parameters out. So A is 20,000. In fact, I'm going to work in thousands in this question, so I haven't got to deal with large numbers. So I'm going to put A as 20. D is £500, £500. So if I'm working in thousands, that's 0.5. And for part A, N is 10. And well, there we go. So guys, see if you can finish those that one before next lesson. This thing about statewide and unsuitable model, no one gets a constant pay rise every year. Something's changed. So that's all they mean with that. But the rest of the work we're going to do on arithmetic sequences is based on these wordy questions. Okay.